Welcome back. In this video, we're going to be working with the same network dataset that I showed you in the Gephi video, but this time around, we're going to analyze it in Python. To do this, I've set up a Python file that I'm just calling networkfun.py, and I need to import the library that I'm going to use to analyze this network dataset. And that library is networkx. This is a library that contains a lot of functionality that will let us analyze our social network. Now, it actually has many more features than Gephi does, and it lets us work with extremely complex datasets. Another good option is the Stanford Network Analysis Project, which also has a Python implementation that you can use to work with extremely complex networks. For the moment, we'll stick with NetworkX, and we'll just walk through how to do this. So the first step is to actually load this data in so I can analyze it. To do this, I'm going to write a helper function because, of course, as you know, I have two files. I have my nodes.tsv, and I have my edges.tsv. Now, you'll note that these two spreadsheets are formatted for input into Gephi. I have my ID, name, and all this extra information. In Edges, I have source, target, and a little bit of extra information. Now, NetworkX doesn't expect a specific format, so it is much more flexible than Gephi. So what I'm going to do is I'm just going to write a little helper function that'll load in this spreadsheet. Now, of course, Python does have a lot of packages that load in CSVs and TSVs, but I'm just going to write something myself. So I'm just going to say something like def get data, and it's going to take a file name in as a parameter. And I'll go ahead and add a comment, helper function to load data in from file. Now I'm going to start with a context manager. So I'll say with open file name, I'm going to read it. The encoding is UTF-8 as RF. Then I'm going to say lines equals rf.read.split on the new line. As I've mentioned in some other videos, I like to do this rather than using read lines because this makes sure that I don't have that /n character in every line. The next step is to separate the data. I'm going to take those tab characters that separate all of the information in these spreadsheets, so these tabs. I'm going to go ahead and split my list into a list of lists where each item in those lists is a piece of data. So I'll just say data equals line split tab, so each line gets split along those tabs for line in lines. Simple enough. Now, I also know that my header is going to be that first item in this list, and the data should just get rid of that first line. So I'm just going to split this list. And that's actually it. Now I just want to return my header and the data. Now, we're not going to be using this header for anything, but in some cases we might. So I'm going to go ahead and set it up to do this. So now that I have my helper function written, I can load in my data. So I'll simply say my node header and my node data are just going to equal get data nodes.tsv. So this will go ahead and load in my information and save it into these variables. I'll also do this for my edges, so the edge header and the edge data equals get data edges.tsv. And now that I have this information inside Python, I can go ahead and use it. So let's talk about NetworkX. The first thing I want to do is I want to create a graph object. Now, if you look at their tutorial, they have a way that they like to do it. A capital G equals networkx.graph, just like this. This will create a graph object that we can add nodes and edges to. So when you're working with NetworkX, it's standard to import it as nx, which is what they recommend. So I'll do this, and I'll make sure I change this to nx.graph and save it. And so now I have a graph object that I'm ready to load my graph into. So I'm going to add a few comments really quickly so it's clear exactly what's happening on all lines. So bear with me for one moment. So now to load in the data, it's actually pretty simple. I'm going to iterate through my node data and add it one by one to this graph. Now, NetworkX does have a function that lets you import using a list, but adjusting individual parameters on each node is a little bit difficult when you do this, so I'm just going to do it one at a time. So I'll say for node in node data, to do that, I simply say g.add node, and the first thing I want to do is I want to give it an ID, which is at node 0. Because if we go back and we look at our nodes here, we see that the first column is our node ID. And I'm going to go ahead and treat this as an integer, because when I load it in, it's going to be a string. I don't have to do this, but I'm going to just for consistency's sake. And then what I want to do is I want to actually add this supplementary information. So I want to make sure that I keep track of the name. And this is going to be at node 1, because we have over here name, Chenjiru. I'll also load in Chinese name and index year just for the sake of demonstration. So I'll say CNAME equals node 2, and then I'll say index year, which is the year that the China Biographical Database organizes people by. I'll say the index year equals node 3, and of course, because it is a year, I'm going to treat this as an integer. Okay? I won't add the others just for the sake of brevity in this video. So what this will do is this will go through each line of that spreadsheet and add that node to the graph. So once I've done this, I can actually make sure this gets added properly simply by saying print g.nodes.data just to see what it looks like. So I'll go ahead and I will open up my Anaconda prompt. And I will click here, and I will do I'll make sure it's there, networkfun.py, and I'll say Python networkfun.py. And it takes a moment to load it in, and now we can see that it's printing out all of this information. So we have node ID, name, Chinese name, and index year. Unfortunately, my Anaconda prompt doesn't like to save my font preferences. That's just something I need to fix on my side of things. Okay, so now we know that this works. These nodes are being added properly. Let's do the same thing with edges. So here, I'll simply say for edge in edge data, and to add the edge, I'll simply say g.addEdge. Now there is add edges from, where I can give it a list of tuples with the attribute information, but I'm just going to do this one at a time because I'm already iterating through this edge list. And then I need to give it the node IDs that are connected by the edge. Now, of course, if we look at our edges spreadsheet, column 0 and column 1 contain this information. So I'll say edge 0, but I want to make sure that this is an integer because I am loading this information in as an integer when I create the nodes. And I'll say int edge 1. So this is all I actually need to define my edge, but I also want to make sure that I am using kin and label information. So I will go ahead and say kin equals edge 2 and label equals edge 3. And so this will load in my edge information. That's actually pretty simple, and now my data is loaded in. And you can see how this is a lot more flexible than the Gephi format, simply because I don't need to have specific column names, and I can really control where everything goes. All of these variable names, name, CNAME, index year, I get to define. I can change them around as much as I want, and these will become the properties that are associated with these different objects in the graph. Okay? So our graph is created. I'll go ahead and comment this. Now you'll note that this is an undirected graph. If we want to make a directed graph in NetworkX, we actually have to specify that up here on line 27 when we create this graph. We would use a slightly different object. We would actually use digraph instead of just graph, but we're going to leave this as it is. So now we can actually start to run our metrics. So I'll just walk you through a couple of the metrics that are available with NetworkX. As you can see on this list, there are a really large number of ways you can study your network using this particular Python package. But for the sake of consistency with the previous video, I'm simply going to show you how to get the degree centrality, betweenness centrality, and closeness centrality of all of the nodes in your network. This is very easy. I'll say degree centrality equals nx dot degree centrality, and I'm going to give it G, which is my graph. And I'll go ahead and fix the spelling here, centrality. Okay? So when I calculate the degree centrality, this will return a dictionary where the node ID points to that node's degree centrality. So I can simply say degree centrality, and I'll give it, say, Chunjiru's ID, and then we can print this just to make sure that this worked properly. Now, these will be weighted, so the results are all going to be below 1. So I'll run this. And we can see that Chunjiru has a degree centrality of 0.000110.5, and so on. So that's great, this worked. Now, to calculate other metrics, it's about exactly what you would expect. Let's say closeness centrality. This equals nx.closeness centrality, and I'll give it the graph. And again, this returns a dictionary where I can grab a value based on a node ID. This metric takes a lot longer to calculate than the degree centrality does. And there we go. So that took a little while. Betweenness centrality is exactly the same, except we use betweenness centrality, and we give it the graph. Now, I don't want to sit here and wait for this to actually spit out an answer, but this is how you get that. Now, you might want to actually visualize this graph, although I should say that Network X isn't necessarily designed specifically for visualization. To do this, we would simply need to import matplotlib, which I actually have done right up here off screen. And we can visualize this quite easily. I can say nx.draw, and it will try to draw a graph for me. And there are a lot of options here. It will draw it in a default way, it'll draw it randomly in a shell layout, or with a spring layout, which is a lot like those force atlas layouts we saw in Gephi. Here, I'll give it the graph, and then I'll say plt.show. Now, I'm not going to run this because, like we just saw, it's a little bit slow when it's working with these really large graphs. And even this, in terms of large graphs, isn't that big, but it would take a while, and so I'll hold off on doing that. But that is basically how you do network analysis in Python with Network X. In the next video, I'm going to show you how to go from a plain text, extract some entities, and develop a network out of that. Okay? So thank you for joining me, and good luck with your network analysis.